So in this video we're going to be looking at how computers represent sound. So the idea is we're learning what frequency and amplitude are of a sound, what we need to do to a sound and an analog sound so we can put it onto a computer, and then finally we're going to talk about this thing called sampling and how we do that so that we can record sounds and save them onto computers. So the first thing to understand is that a sound is vibrations that are travelling through some kind of media, be it a solid, liquid or a gas. If you're hearing a sound wave, what you're hearing is vibrations in the air molecules, and that causes your eardrum to vibrate and your brain receives that as a signal which it interprets as sound. Now, we measure sounds. There are two things we measure in sound. The first thing is frequency, so this is how often the sound waves go up and down per second, the number of cycles per second, and in science you measure that with a unit called a hertz. So 1 hertz is 1 cycle per second. That means the wave, you'd see one of these peaks in the wave per second. And so because the peaks in the top wave are further apart, they're happening less frequently, we can say that the top sound has lower frequency than the bottom sound here. Now, the other thing that we also measure is this thing called amplitude, which is the loudness of the sound. And for that, we simply measure the, if you like, the height of the wave, and we measure that in a thing called decibels. Excuse me. So if you look at these waves here, we want the top here because this has got a lower, the wave has a lower height, a lower amplitude than this one over here on the left. We can say the one on the left here is quieter and the one on the right is louder because the wave's higher. Looking at this bottom pair, the one on the left here, we would just see one peak and then we don't see any, we don't even see the trough on this wave, but on this one here, in the same amount of time, we see 3 peaks. So that means it's got a much higher pitch, this wave at the higher frequency than this one on the left here. Now, true sound, it looks really, really complicated. So this isn't a trace of a real sound wave, and it will look like there's loads of different signals there. But on the computer, we can't unfortunately store these because you can't store a continuous signal. As we said when we looked at binary, on computers, we need to be able to store things as numbers. Once we've got them as a number, we can store it in binary, but we have to turn it into a number first of all. So we use this process called sampling. Now, sound is analog, so that's the sound that you're hearing is an analog sound, and in the physical world, continuous and infinite number of states and ranges of sound. But on the computer, we need binary. Everything needs to be binary, so we're going to sample it. And this is sometimes called digitizing the sound, which turns it into a series of binary numbers so that we can then save in a file and call it a sound file. So the first thing we need is something to load the sound into the computer with, and for that we use a microphone. And that works by taking the vibrations in the air molecules and turning them into an electrical signal, which we can then digitize. And then to output the sound, you're going to use speakers. So you're either going to use big speakers or little speakers you put in your ears called headphones. And they work in the opposite way to a microphone. We feed the electrical signal in and they cause some kind of diaphragm to vibrate, and that creates a sound wave that you hear. Now, the way that we turn the analog sound into a series of numbers is by this magical process called sampling. So if you take the sound there, so imagine the red thing is the sound wave. What we're going to do is at regular intervals, we're going to measure the wave, and we measure the two properties. We measure the frequency and we measure the amplitude. So you go kind of 1 unit in, measure the frequency, amplitude. Another unit in, measure the frequency and the amplitude. Another unit in, measure the frequency and the amplitude. And all you do is these are just 2 pairs of numbers which you can then store in a file in binary format, and that allows you to take an analog wave and represent it in binary format. And if you're taking something like, say, an MP3 sound, you'll be making these measurements, about 128,000 of these measurements per second. So we make a lot of measurements. Now, the more frequently you sample the sound, so the smaller the gap between the samples, the more accurately you represent it. So if you look at these 2 graphs here, the green is the original sound wave and the red blocks are what the computer would actually store. And you can see on the left, it's quite got the kind of the red shape doesn't look a lot like the green shape much at all, and that's because it's missing lots of pieces of information. So if you look down here, we don't even record we record the low value, but we don't record, for example, this value halfway between this point here and this one here. On the right hand side though, because we've got smaller gaps between the samples, we can make many more measurements. And if you squint at these graphs, the one on the right looks a lot closer to the original than the one on the left, and that's because we've sampled more frequency. So a higher sampling rate means much more accurate representation of the sound, but it also means got more data to store, so the file gets bigger. Now, the other thing you can also sample is the amount of information you measure per sample, and that's measured by a thing called bitrate, which is, so again, low bit rate, you've got less data to store, so smaller file, but high bit rate, you get much more accurate representation of the sound, and therefore you get, but you also get a larger file, so you get better quality, but a larger file. Now, if you're listening to sound, obviously this thing here on the left here is a vinyl record. This will give you a true representation of sound. It is actually a direct copy of the sound that you heard. The CD might sound better, but it's actually not a true representation of sound because it's just a series of beeps, really, just beeps that happen very, very frequently. But that's the process that we use to take an analog sound and turn it into a digital sound.